Did you know you're a secret mathematician? Yeah, you. And you probably don't even realize it. Every single time you glance at a clock, you're tapping into this really powerful system. A system that also happens to secure your online data. So today, we're going to pull back the curtain on the secrets of what's often called clock math. Alright, let's just jump right in with a super simple question. If it's 9 o'clock right now, what time will it be in 5 hours? Go on, think about it. It's 2 o'clock, right? Of course it is. Notice how you didn't say 14 o'clock. Your brain just automatically did the math. It hit 12 and just wrapped right back around to 1. Well, guess what? You just solved the problem in something called modular arithmetic. See, you're already a pro at this stuff, and you didn't even have to think about it. Okay, so what exactly is this clock math that you've apparently been using your whole life? Well, it all comes down to thinking in cycles instead of just straight lines. So, modular arithmetic is basically the mathematics of cycles and remainders. Think about it. Instead of a number line that just goes on and on forever, these numbers wrap around once they hit a specific point. And that special value, the one where everything resets and starts over, that's called the modulus. So for a 12-hour clock, the modulus is, you guessed it, 12. For the days of the week, the cycle is 7 days long. So the modulus is 7. Simple, right? Alright, so let's get into the nitty-gritty. How do we actually do math in a circle? The rules are honestly super simple. In fact, you kind of already know them without even realizing it. First up, we've got modular addition. It sounds fancy, but it's exactly what we do when we are figuring out time. It's a simple two-step dance. First, you just add the numbers together like you normally would. No tricks there. Then, you take that sum, you divide it by the modulus, and you find what's left over. That remainder, that's your answer. That's the whole game. Let's try one. Say we want to know what 8 plus 7 is, using our clock modulus of 12. Okay, so step 1. 8 plus 7 is 15. Easy. Step 2. We divide 15 by our modulus, 12. Well, 12 goes into 15 one time. And what's left over? A remainder of 3. So in clock math, 8 plus 7 equals 3. It's not 15 o'clock, it's 3 o'clock. See how that works? Subtraction works pretty much the same way, but with this really clever little trick for when you end up with a negative number. I mean, what even is negative 5 o'clock, right? Well, there's a really simple fix. Again, you just subtract normally. But if you get a negative answer, you just add the modulus to it. That brings it right back into the positive cycle. It's kind of like winding the clock backwards to see where you land. So check this out. Let's do 4 minus 9. Normally, that's negative 5. To figure out what that means on a clock, we just add our modulus, which is 12, and negative 5 plus 12 is 7. So 9 hours before 4 o'clock was 7. Makes perfect sense. And finally, we've got multiplication. And I bet you can already guess the pattern here. You multiply the numbers, and then you find the remainder. Yup, it's that same two-step logic. You calculate the product of the numbers first, and then you just divide by the modulus to figure out what's left over. So, for example, 5 times 6 is 30. Using our modulus of 12, we just divide 30 by 12. Well, 12 goes into 32 times, which is 24, and that leaves a remainder of 6. And there's your answer. Okay, this is all pretty cool, but why does it actually matter outside of telling time? Well, it turns out this idea of cyclical math, is one of the absolute cornerstones of our modern digital world. You know, our source material for this, which was a guide for top teachers in Nigeria, puts it perfectly. This stuff isn't just some abstract idea for a math test. This is literally the secret code running in the background of your daily life. And this is where it gets really amazing. Clock math is the foundation for modern cryptography. It creates these cycles of numbers that are so huge, they are basically impossible for a hacker to guess. It's also used to check if things like Nigerian bank account numbers are valid, or even network IDs. It's this hidden layer of logic that's constantly working to keep our digital world secure and running smoothly. So now that you've seen the rules, and you've seen just how important this is, it's your turn. Let's put your new skills to the test with a final little problem. Okay, imagine a password that changes every day. but it's on a 7-day cycle. So our modulus is 7. If today is Wednesday, let's call that day 3. What day of the week will it be 150 days from now? Go ahead. Use the rules of addition and remainders we just talked about to figure it out. And really, that's the big take in here. Our world, from the seasons to the tiny circuit inside our phones, runs on cycles. And the key to understanding, predicting, and even building with these cycles, it all just comes down to the remainder.